Hi, my name's Emily from Team Mix-a-Lots, and I'm going to walk you through our program called MixMatch, where we compared the performance of two shortest path algorithms, Dijkstra's and A-Star, for creating a seamless playlist of similar songs based on two input songs. So the idea is that users can choose two songs that they like and get a list of songs that smoothly transition between each other based on their unique characteristics, such as tempo, valence, duration, danceability, etc. So first, let me walk you through our code, which you can access by cloning our GitHub repo, creating a virtual environment, and installing the requirements text file. Here we have code to clean and combine our two Kaggle datasets. It outputs a data frame that includes around 115,000 Spotify songs, along with various quantitative and qualitative features for each song, which we use to build our graph. All the features are normalized from 0 to 1, making sure all the values are positive so that Dijkstra's and A-Star can work, and making the node comparisons straightforward. This code here constructs a weighted undirected graph of the songs. Two songs get an edge between them if the sum of the differences across the numerical categories is less than 0.25. And we use scikit-learn's nearest neighbors, which uses a ball tree under the hood to make the edge comparison process more efficient. This code here implements the two algorithms that we're comparing, Dijkstra's and A-Star. And finally, this code is what we actually need to run our program, and it combines all the previous functions along with our UI. So now let's run our program and do a quick demo. So here, users can search for the first song that they want in their playlist. For example, we could choose this, and then here, users can choose the last song they want in their playlist. For example, we could choose this. And then here, you can choose which algorithm you want to run and click Find Connection. It'll take a second to run. And it will output with our first song you can see and our last song and the playlist of songs in between, also giving us the distance and the time it took. And now we could compare this with A-Star, which runs much faster. We can do one more quick example. So we can search for our song and our second song. And choose Dijkstra's. We can see again, we had our first song with arrows to all the songs in our playlist, the distance and the time, and finally we can compare with A-Star, which was much faster, and see the same outputs. So that's our Project 3 program that we made. Yeah.